inspection of sieves and screen guide. A presentation to identify sieve and screen kit components and method of inspection. Index, Introduction, Components, Application, Step-by-Step Uses Guide. Introduction. Sieve are mesh made of metal, fiber or cloth, assembled to provide defined openings. Sieve are used to screen and separate powder into various size fractions. Generally, particle sizes larger than 250 micrometers are unsuitable for power metal process. A real-life example of a sieve is a tea strainer, which is used to separate tea leaves from the water. The sieve presents the large particle which cannot pass through the holes in the sieve and retain them on the sieve. Different type of screen: CAD mill, commuting mill, polarized mill, oscillator, granulator. Screen are models of cone mill screens such as quadrico mill, G mill. Detachable type filtration pot, also known as DC pot. Fixed type filtration pot. Multiple screens. Component of C inspection kit: linear mesh counter, nominal aperture calibrator 8x zoom, pocket microscope 30x zoom, densimeter type A, B and E, pin gauge, go no go. Linear mesh counter or pig gauge is used to measure wire mesh. Mesh number is determined as number of openings per linear inch. For example, let's discuss about 40 inch. It is 40 openings in 1 linear inch. The LMC is having magnification of 8x. The figure below shows a simple linear mesh counter. Procedure for operation. The glass or gauge consists of two surfaces on which one side is of magnifying glass and the opposite side is of calibrated scale. To inspect the wire mesh, place the calibrated scale on a wire mesh surface as shown in figure. The calibrated scale must be in line or parallel with the wire. Observe the mesh through the glass and count the openings of 1 linear inch. And count start from ending of one wire to the start of the last wire at the end of linear inch. For counting the wire mesh finer than 40 mesh, then the opening must be counted on 1 by 4 inch scale, then multiply the number of openings by 4 to get the exact mesh size per linear inch. The smallest section of the linear mesh counter is 1 by 8 scale, and this can be used for counting meshes finer than 60 mesh. To calculate this, count the number of openings in the smallest section from the ending of one wire to the starting of the last wire. Then multiply the counted openings with 8 to get the wire mesh count per linear inch. Nominal aperture calibrator 8x. Nominal aperture calibrator is equipment also known as mobile microscope as a given figure in the PPT. Procedure for operation: before starting the device, it must be fitted with 1.5 volt of two batteries on the back side. It is calibrated as one interval is equal to 0.1 mm, means one interval is 100 microns. Procedure for operation: this device used to count the wire mesh opening. Put the calibrated side on the wire mesh, look through the lens, count the number of openings within the scale range. The scale is calibrated with 0.1 mm least count, and one division on scale depicts 100 microns if we get 8.5 or 8.7 division on scale, which is within one opening of wire. It is shown that the wire mesh is 870 microns, which when converted to the table given as 20 mesh. Hand microscope, also known as pocket microscope, device used to check the defect in wire mesh and perforation of sieve and screen. It is consists of LED light to illuminate the observing area and eyepiece with adjustable lens to zoom in or out. The following figure shown as illuminated pocket microscope. Densimeter. In 1874, a Nobel Prize winner named Lord Rayleigh recorded graticular figures which occurred when superimposing very fine grids on top of each other. The optical phenomenon was later designed by the term Moir because of watermarked effect. The lunometer or densiometer is a commercial instrument made of artificial glass with etched in the grating line. By placing this instrument on a wire mesh surface, the line of the instruments are coordinated with the structure of the wire mesh. Superpositioning interference of the two grid system will be observed. Since the grating of the instrument is one with linearly increasing grid constant, there must be somewhere in the interface field a zone where there is complete harmony of both grating wire mesh and calibrated line. The scale beam provided one on the side of the instrument indicates the density value of grating or wire mesh. Tensimeter. The lunometer is all used mainly to determine the thread density, thread or thread count, or any wire mesh or knitted object having a parallel structure. Example, a linen weave for the purpose. The instrument is laid as parallel as possible to the thread direction to examine on top of the sample. An interference pattern will appear immediately, taking the shape of an oval. Complete pattern in the case of parallel grid system, in a hyperbolic form in the case of radial grid system. The middle axis of the interference picture is important for the accurate reading of the third count number of picks based on the instrument scale. The number of laterally running threads, warp threads, can be ascertained in the manner by slowly rotating the instrument. The Moore pattern changes and disappears almost completely at each angle of 45 degrees. On further rotation up to 90, the Moore pattern will again emerge quite distinctly and we now relate to the laterally running threads. Measurement can be carried out in daylight without any artificial lighting. Pin gauge go no go. The pin gauge is a pin-shaped fixed size precisely cut cylindrically bars come in various sizes. The primary purpose of pin gauge is to measure and inspect the diameter of small holes. It also be used as a test bar for geometrical deviation and measurements. Thank you.